Hi, my name's John Paliotta. I manage a research group here at Vector that focuses on new ideas for software testing and for software quality. Today, my presentation is going to talk about ideas for improving test efficiency. I've got four major sections to the presentation, and then we'll leave a little time at the end for your questions also. So, what is efficiency and why are we talking about it? To me, efficient testing prioritizes tests that are likely to fail, therefore find bugs, and tests that are checking important features of your application. So, why does this matter? Well, most of us have a lot of test cases, and it takes a long time to run all of them. So, the longer it takes for a test to fail, the longer the time is between when a developer makes a fix or is done implementing a feature and when we find out that some of the existing or new test cases aren't working. And so this affects everybody. It affects QA because they have to figure out why the test cases are failing. It affects the developers because if it takes a long time, they context switch to some other project they're working on, and then they have to come back and figure out what they were doing. And then customers end up waiting too long for a feature. So if it takes a long time to run all the test cases, why do we run them all? Well, we primarily run them because of something we've all run into in our careers. The developer who says it's a one-line change, it doesn't affect anything else, and we can go ahead and integrate it. And we've all been burned by that, where the one-line change breaks a whole bunch of stuff in the application. And so because it's hard to pick the right tests, we end up running all of the tests. And running all of the tests is okay if they all pass, but it's not that great if the last one in 12 hours of testing is the one that fails. So ideally, we want all the test cases to pass, which is great, or we want to fail fast. So if you remember anything from this presentation today, remember those two words, fail fast. That's what we should all be thinking when we think about our test environment. So let's just think for a minute about why tests fail and also why they pass. So test cases that fail because of real bugs are great. Test fails, it's a bug, we fix the bug, test case passes, great. But we all have fragile tests, and those are tests that don't find real bugs but still fail. And then let's think about why test cases pass. So, we run 100 test cases, they all pass. Does that mean we have a correct application? Maybe, but maybe the test cases we ran aren't really related to the changes we just made. So the rest of the presentation, I'm going to talk about these things. Basically, how can we understand tests better, understand what our tests are doing? We'll fix the fragile tests, get those out of the equation, get rid of any tests that are unnecessary, extra tests, make sure we have sufficient tests for the features that are important. And then after we've done all that, some ideas for how we can prioritize our test cases. So let's start with understanding our tests. What are we doing when we're testing? Do we know? Do we have good visibility into what we're running and why? The focus for most of us building software is on the application code. So we've got lots of tools for that. We run lots of tests for the application code, but do we really think or apply the same degree of rigor to our test process in the test cases themselves? The problem with software quality is rarely that we don't have enough test cases. All of us have hundreds or thousands of test cases, but we don't necessarily have the best test cases. So to understand our tests better, let's start with some questions. Do we know what a test does? Is it easy to figure out what a test does if I just pick out a random test from all of our tests in our test suite? Can I figure out what it does easily? Maybe not. And how often do we review the tests that we're running? And do we ever delete a test? I mean, often test case creation happens along with the code, but do we also get rid of some of the older tests that we might not need anymore? And how often do we change the order of test execution? So the first step is to start collecting some data about our tests. Maybe some of you already have this data. The data I'm suggesting we collect is pretty straightforward. Everybody should be able to do this. So let's build a database so we have a history of all of these attributes. And the first thing you should do is for each test case, assign it a set of features that it tests. These are user-facing features. Use a tag approach, I think, makes a lot of sense. You can choose any approach you'd like, but it's important to know why a test case is there very easily in a consistent way and what the point of it is. Then we need, of course, the pass-fail history for each test. And it's important to have this data for every time a test runs, not just when QA runs it pre-release. So we need lots of iterations of the test to really understand what it's doing. And then we can compute easily the frequency of failure, how many times it fails out of the total runs that have been made with it. And then we need to understand how old a test case is. That should be easy to get out of your SCM system. And then its modification history. And then over time, there might be other things that are interesting for your project. And feel free to add those in. And also, this is not intended to be an exhaustive list. But the important thing is that we have consistent data. So come up with a consistent way to identify your tests, a consistent ID or a naming convention. And then we for sure need programmatic access via an API so that we can slice and dice this data to draw conclusions from it. Once you have this data, there are a lot of ways to analyze it, but I'm going to suggest two things that I think could be valuable. The first is to sort a test by how often it fails. Sort your list of tests by how often they fail. So tests that fail frequently are often great tests that find real errors in areas of the application that are changing rapidly. Great, those are great tests. But I guarantee you have some tests that fail a lot that are terrible tests. And I call the terrible tests fragile because they waste a lot of time. And then you have tests that seldom fail or never fail. And that could be because we're not changing those features. So that's great. They're stable, they work perfectly, but there might also be some redundant or obsolete tests. Another way to sort things is by feature importance. So if for every tag that you assign to a test, as far as a feature area, if you then rank those and sort those by their importance, it'll be interesting to look at how many test cases you have for each. And then again, as always, let's look at outliers. So if you have a minor feature and you have a lot of tests for it, I mean, it's not necessarily bad, but it's definitely an area to look at. And then if you have a really important feature with very few test cases, fewer than average, again, this might be another area to look into more carefully. So once you've done this simple sort, and there are many others you could do, but if you do this simple sort, it leaves us with sort of 4 groupings to dig into a little bit more. So tests that fail a lot, you want to sort of go through those and divide those into ones that find bugs or ones that are fragile and fail for seemingly no reason or for a reason unrelated to the change being made. And then you have major features with too few tests. I think that's another important one. So those 2 on the top are really important ones. And then you might also find some test cases that never fail, as I mentioned, and maybe some of those are obsolete. That's why I have a question mark there. And you have some minor features that seem to have a lot of test cases. Maybe you have too many. So those could be candidates for removal. So let's talk about fragile tests. As I said, fragile tests are tests that fail and don't catch real bugs. And the worst thing about fragile tests is they end up destroying confidence in your whole test process. So the sort of first exercise is to think about how your developers react when they run into a test failure in the test suite. Is it any of these things? The first 2 are like pointing at fragile tests, right? And then if it's really seen as, a failure, I better dig into this, then that's an indication that your tests are doing the right thing. And there are a lot of types of fragile tests. So often people think of fragile tests as related to timing, in that sometimes they fail and sometimes they pass. But sometimes it's not the test that's fragile, it's the application that's fragile. So maybe that needs to be fixed too. And we're not going to talk about that today. That's a topic for another day. But, so I do mention the intermittent failures, timing related, but also people often have large tests that have too many checks in them. And oftentimes the check is unrelated to the core reason that the test was created in the first place. And I'll talk about that in the next slide a little bit. And then we often build test cases that are really tightly coupled to the implementation. And again, that's a bad thing because when the implementation changes in a way that shouldn't affect the end user, test might fail. So I'll talk about both of those in a little more detail in this next slide. So the first category is intermittent failures. And so we've all run into these, and the worst solution possible is to add sleep calls into the test, to just wait some deterministic amount of time, like 1 or 2 seconds, 3 seconds, 12 seconds, And then what happens, you run on a new machine that has more processing power, more memory, and the application runs faster. So then you're messing around with your sleep calls. That's horrendous. Please don't do that. If you do have to sort of synchronize with the application, and there's another idea on this slide also later on, but a deterministic call that can wait for something to occur. So maybe a message is sent from the application and you can trigger the test continuing, waiting for that message. Something deterministic. It's really important. And then I see this a lot where people have large tests that have too many checks in them. And really, we want tests to be relatively small, right? And with a pretty well-defined purpose, pretty small amount of preconditions and a pretty small amount of expected values. So a quick example of this might be, suppose your application produces a JSON file, and there's probably a lot of data in there. And an easy way to sort of test that would be to capture the JSON file and then diff it. But suppose you add a field to the data in the file. I mean, it's unrelated probably to what your existing test is doing, but your test is now going to fail. So this is another flavor of fragile tests. And so in this case, what I'd suggest is read the JSON data, pick out the key things that you're really trying to check for in the particular test you're writing, and then leave the overall structure of the JSON file and the fields that exist in it to a single test. And then if somebody adds a field, great, that single test fails, but not every test that deals with the JSON data. And just tests closely coupled to the implementation. They might reference application internals. You think about testing graphical interface, maybe you have a Qt interface, and if you start using the names of the actual widgets somehow in your testing, that's pretty bad, because if the developer changes the widget name, your test is going to break, and that should be his prerogative or her prerogative to change the names. So if you do need this tight coupling, it's fine, but you should have the application folks build a test API that can expose anything that you need to key off of that's private. And then also another approach can be to derive test cases from a common source. So if you're doing C or C++, maybe you derive your test somehow from the header that's also used by the application builder, so you don't have these hard-coded magic numbers in two places. And then I said the fragile applications will leave to another time. So as with everything, getting rid of fragile test cases is going to take some teamwork. So basically, we want to go from no matter how many we have down to none. And so some of them might be easy to fix. It's just laziness that we haven't gotten around to it. So let's fix the easy ones. And then the harder ones, maybe think in terms of not replacing the whole thing, but maybe we take the good parts and we replace the good parts, and we carve out the parts that are really bad and we leave that till later. Because what we want is we want a test suite that's free of fragile tests so that everybody can have confidence. And the absolute worst choice you can make is simply to disable the test and leave it sitting there so that everybody's staring at it and knowing we have these disabled tests. Next, we'll talk about missing and unnecessary test cases. So the two ends of the spectrum, the two outliers. So it's really important to always be thinking, are we testing the right things? Like, what are we testing? And part of my presentation today is just to hopefully help you think about what are we doing when we're doing all of our testing, right? To make sure we're doing stuff that gives us the best return on investment for our time. So code coverage is a great indicator of testing completeness. Vector has a couple of code coverage tools that are available to help you with that. But feature coverage is also important. So now that we've got the information about test case to feature correlation because of the tags, we can assign importance to each of those tags. So we have low, medium, and high, kind of a minor feature, medium feature, and major features. And then we can sort that list of tags by the test cases per tag. And then we can cut them into segments, the three segments of minor, medium, and major features. And then we'll sort of get an average number of tests for each of the three sets. So this is going to help us in multiple ways, because part of this exercise will help us to sanity check the tags we've created. So if you haven't created enough tags, then everything, half the tests might be in one group. It might be like API. Well, okay, probably half the tests aren't related to the API, or maybe they are, and then you need some sub tags under API for the different features. So you might have too many tests tagged one way or another. And it also, importantly, for this section, allows us to identify under-tested features that are important and over-tested features that are not that important. So both of these are sort of important. I put question marks in the red square because just because you have only a few tests for a particular feature, maybe it's enough. Maybe it's a pretty deterministic feature without a lot of variation. And so you only need a couple tests. So it's not necessarily bad. And in a similar way, it's not necessarily bad if you have a lot of tests for something that's a relatively minor feature, because maybe it has a lot of complexity to it. But again, these are just areas to point you at to make you think a little bit. So once you have this data, obviously adding tests is straightforward. I'm not going to tell you how to add tests, but how about deleting tests? We've got two buckets now at this point. We've got the sort of never or seldom fail, and we've got the not minor feature with a lot of tests. So why don't we normally go through the process of deleting test cases? And again, fear, we're afraid of breaking stuff, right? And we might not know what some, all, or any of these tests do. So, they've been around maybe 10 years or so, and everybody's afraid to delete them. Final thing I'll say on this topic is all of us can probably get buy-in from our team to refactor ugly code. We all know the code that's kind of ugly. We need to apply that same sort of mindset to refactoring sort of the ugly test cases. And the final topic now is, after you've done all this work, how can we prioritize the remaining tests? So we've gotten rid of the fragile and unnecessary tests. We need to think about what order we run the rest of the tests in. So how do we choose our execution order? A lot of us have no idea. It's a black box. Oftentimes it'll be a static execution order. So it just runs, alphabetically. I don't know. It runs by the folders of tests that we loop through in our test process. It could be that it's a static order, but we always add new tests at the beginning of our run. So that's slightly better. Random would even be better than a static order, because random at least will give you a chance of a test that's going to fail to be run earlier in the process. So as I said a minute ago, the thing to keep in mind, we have limited resources. And so let's prioritize our tests so that we run the ones that are most likely to fail sooner rather than later in our process. So the first step, we've gained a lot of knowledge about our tests. We've done some filtering. We've gotten rid of some tests, hopefully, at this point. So let's leverage all that knowledge to dynamically choose an execution order. So there are a lot of ways we could do this, and I'm just going to present a really simple approach that I think makes sense. So just to recap our accomplishments, right? We got rid of the fragile, unnecessary tests. We've added new tests. We now have attributes for every test for how important it is and how often it fails. We've ranked our features by importance. So let's use this data now to create 9 sort of buckets, right? I know it's a table. We don't really have buckets, but if you look at the frequency of failure and sort of separate that into 3 segments, often, sometimes, and never. And then you also look at the importance of the feature and treat that as high, major feature, medium, low, minor feature. Then you get these 9 numbers of tests, right? And it's pretty okay if a lot of your tests are in the middle, sort of medium importance, and sometimes fail, but not all of them, right? We can't have all of them in that center box. So this is another sort of QA test on the work you've done to this point. So sort of the assignment of tags and the prioritization of those tags and everything else will sort of show up here. The other thing that's important is this needs to all be done programmatically, right? So I talked about having your data accessible from an API. So that's important here. We need to be able to build this data, dump this data out with no effort, really, once we've built our tools. So once we've done an iteration of this data and we sort of like how the table looks, then the next part is to sort of group things within these 9 buckets into 5 priority levels. And as I mentioned in the last slide, we've got our high importance feature, fail often, right? Non-fragile, failing often. So that's, number 1 priority. And then Number 5 is minor features, and the tests for them seldom or never fail. So those are the 5s. And then everything else I've scattered here into 2s, 3s, and 4s. And I also suggested how many tests of your total number of tests should be in each of the 5 priority levels. There's nothing magical about this, so make your own judgment. But clearly, you don't want everything a 1 or everything a 5. You want some sort of distribution that's reasonable. And then we simply want to run our test cases in priority order, 1 through 5, and see if we fail faster. And there are infinite numbers of adjustments we can make to this. So we might run a few times, look at the data again, we move tests around, add tags, de-emphasize tags. Maybe we run them in a random order within each of the 5 groups. So we have 100 tests that are in the 1 priority level. Maybe we run them randomly each time we run within that group. Or maybe we run the newest ones first within each priority level. A lot of options. And then let's refine what we're doing. So one of the things that I'd suggest before you even run, once you have your algorithm and you have all the data, maybe we back check it. If you do have historical data for test runs, no matter how far back it goes, compute the order that you would have run the test cases in, and then compare that to the order that you did run them in, and see if you fail faster with the order that is produced by your algorithm. So that's a great way to refine things too. Let's back test against any historical data that we do have. And as a control, maybe back check the algorithm in the actual order against a random order to see if random order would even give you better results. As you improve the algorithm, it's important to also improve the inputs to the algorithm. So I would constantly be looking at the tags that you've defined and the tag importance. I would publish that to my user community. I'll let everybody contribute to that. Make sure that your process of refinement is continuous. So every time you run tests, the data should feed into the algorithm and give you a better test execution order for the next time. And then finally, if you have other data available to you, like function coverage, you can feed that into your algorithm because that gives you an association between functions and test cases. And then if you want to use the API to your SCM tool to get information about file changes, you could associate file changes with breakages too. So finally, in summary, just some things to take away, maybe that understanding our tests, while it seems obvious, you're going to be able to refactor your tests if you have a better idea, know more about them. And then if you refactor, your testing is going to be more efficient. If your testing is more efficient, you're going to be able to run more test cases per unit time that you have available for testing. And so you get quicker turnaround, better quality, bugs found faster, and then obviously improving quality, hopefully makes all of your customers happier. And remember our motto, fail fast or not at all. So thanks for watching the presentation today, and I'd be happy to answer any questions you have.